All right, everybody. What's happening, my mathletes? That's right, Mr. Muscarella coming at you. In this video, we're going to take a look at graphing and evaluating piecewise functions. So what is a piecewise function? A piecewise function, that's just a function that has different pieces. Now, in previous courses, like you'll take a look at a function, like just say y, ooh, that's kind of gross looking, y equals 2x squared plus 3, and it's like, all right, that's just one function. Whereas maybe we'll have another function, so say g of x equals 3x minus 5. All right, that's another function. Now, if we have two functions that we put together and say, oh, only graph part of it, that is what rolls the piecewise function. So we're going to have, instead of just one function we're graphing, we're going to be graphing 2, 3, or sometimes more, but only pieces of them. So when we take a look at this example 1 right here, let's check this out. We got x squared minus 3 as one piece. And we're only graphing that from x being smaller than 1, less than 1. Then we have the other piece of 2, and that piece is going to be graphed for values of x that are 3 or bigger. So when you do this, what we're going to do to start with is we're just going to make a little xy chart. We're going to start with one piece. So the x squared minus 3 piece is where we're going to begin. Now when we make our little table, we're going to analyze the first piece. X is less than 1. And even though it does not include the value of 1, we're going to go ahead and put 1 in there. And then I want numbers that are smaller than 1. We're going to use integers, so 1, then 0, then negative 1, and negative 2, and so on and so forth. We wouldn't stop. We'd go on forever and ever. From here, we'll just plug each one of these values into the x squared minus 3 formula. So that would mean 1 squared minus 3, 0 squared minus 3. Negative 1 squared minus 3, and negative 2 squared minus 3. So we would plug each one of those x values in. They're my input values. The answer is my output, or my y value. So when I evaluate each one of those pieces, the very first one, 1 squared is 1 minus 3 is negative 2. 0 squared minus 3 gives me negative 3. Negative 1 squared, be careful here, that's positive 1 minus 3. We get negative 2 again. And negative 2 squared minus 3 gives us 4 take away 3 is just plain old 1. So these are my values right here. Now when I look at this point here, so this is going to be the point 1, negative 2. When I look at that, I analyze this symbol, right? And the symbol is a less than, so that does not include the value of 1. So because of that, I have to remember that that symbol means open. So when I plot the point 1, negative 2, so let's go over here to our graph. So 1, negative 2, I've got to be sure when I graph that I put an open dot at 1, negative 2. All the other pieces, all the other points, they're going to have a solid dot. So at 0, negative 3, that'll have a solid dot. And then at negative 1, negative 2, that'll have a solid dot. And negative 2, 1, that'll also have a solid dot. We can kind of see a parabola starting to form here, but again, we're only graphing that piece. And that's it. That's all you got to do. So we're not graphing the whole parabola, we're only graphing that piece of the parabola. So that's that part right there. Now, we have a second piece, and that piece is going to start here where x is greater than or equal to 3. So I'm going to write this down, this equation here. It's not really too much of an equation, it's just a value of 2. But I want numbers that are 3 or bigger. So my input values are going to be 3, 4, 5, 6, and I can keep going on and on and on all day long. When I plug those in, there's no variable in that piece. It's just the number 2. So I'm going to have all of my answers are just going to be 2. So when I go to plot that piece, there's, again, something I want to pay attention to on there. This piece right here, because of that symbol that's there, that's going to be a closed dot. So some of you might remember this from your Algebra 1 days, but that's how we got to make sure we put that in as we draw that piece. So at the coordinate 3, 2, that's going to be a closed dot, right? So 3, 2, boom, we put a closed dot right there. And then 4, 2, 5, 2, it's just going to keep going on this way forever and ever and ever because it doesn't end, right? And that's all you got to do to graph that piecewise function. So that picture would be the representation of our piecewise function. Now comes the second part, we got to evaluate it. Some people just kind of look on the graph and they'll know which piece to pick. Are they going to pick the piece that's on the left, or are they going to the piece that's on the right. So we've got two options here. So when I look at the value here, when I take a look at 7, I have to say to myself, where on this x-axis? So here's my x-axis. Where does 7 reside on there? So when I look at that, 7 is actually, that's just right over here. 7's over here. So I'd put it into the piece that is just this equation here. That's just 2. So no matter what my input value is, in this case it's 7, my output value is always going to be 2. Now for B, when I'm looking at f of -4, so on this one, I'm like, all right, well, where's -4? So if I look at -4, that would be this spot right here. So if that's that piece right there, the one that the equation, the piece that I'm going to put it in is going to be the x squared minus 3 piece. Only I'm going to input -4 to that value. So I'm going to say, all right, well, that is going to be -4 squared minus 3. Because again, that goes in the x squared minus 3 piece. Be careful here with your arithmetic. That'll give you 16 minus 3, which just gives you a value of 13. So f of -4 would be 13. And if we look at our picture, that kind of makes sense because we'd go way up here somewhere on the y-axis until we get to 13, and then we would have, that'd be another dot, another point on that function. So our very last one. Tricky, tricky, tricky one right here. Check out this guy, 2. If I look on my picture, where is 2 located? So 2 is located right here. Well, if I go up or if I look down, there is no part, neither piece is in that area. Neither piece is in that region. In fact, everything in between, like right here, in between those 2 pieces, is called like no man's land. That's kind of how I think of it. No function's graphed there. And if you don't have a part of the function that is graphed in that area, bro, that's what we just call undefined. So that piece is undefined. So that's all you have to do. So there's basically 3 steps, right? That very first step, you want to make a table of values. So the first step is table of values, right? You want to do that and evaluate that. So you'll do that for each piece. The second piece is once you have your table of values, you're going to go ahead and graph each piece. And that's it. When we do the graphing, again, be careful, be aware of whether you use the open or closed dots, right? So be careful to make sure you use the appropriate dot when you go to graph. And then the third thing is, after you graph it, if you have to do any evaluating, just make sure you plug it into the right piece. And that's it. So that's it for example number 1. We got 3 more examples, so I'll let you come back and watch those in the next video, and I'll catch up with you guys later on. Peace out.